Good morning, class. Yesterday, I have told about the refraction of light. Refraction of light means bending of light when it goes from one medium to another medium obliquely is called refraction of light. Means whenever light goes from one medium to another medium, it bends from its original path, and this phenomenon is called refraction of light. Then I have told about the interface, the types of medium, and how light bends when it goes from one medium to another medium. It may be rarer to denser or denser to rarer. So today we will study the laws of refraction. Okay. So laws of refraction. Laws of refraction. So there are two laws of refraction. How many laws are there? Two laws of refraction. First one is the incident ray, the refracted ray, and the normal at the point of incidence point of incidence lie on the same plane. Clear? So suppose we have a interface and this is incoming light or incident ray. At the point of incidence we can draw a normal, and this is refracted ray. So all these three means incident ray, refracted ray, and normal at the point of incidence always lie on the same plane. It is these three are on the same plane. It should not be like this. So this is our incident ray, this is our normal, this is refracted ray. So this should not be the case. Okay, so these three will always lie on the same plane or the same interface, we can say. Now the second law is, which is little bit typical, that the ratio of sine of angle of incidence to the sine of angle of refraction is constant. Now what does it mean? The sine means sine I divided by sine r is always constant for given media. Okay, this will always be constant for given media. Suppose we have air and water. So let this is air and this is water. So light is going from rarer medium to denser medium, and the sine of this angle to the sine of this angle is always constant for air and water, and this value will be constant. Either it may be 1.4 or 1.3, so it will be always constant. Okay, so now what is sine I and what is sine r, that we have to study a little bit. Okay, so you might be confusing what is sine I, what is sine r, and how will we get the value of this. So I will tell you. Suppose we have two right angle triangle. Okay, one right angle triangle is smaller and another one right angle triangle is bigger, a little bit bigger. So let this angle is theta, means it may be 30 degree, 45 degree, 60, 90, 75, anything. This is 90 and this angle is also theta. Suppose this is 30, so this is also 30. Okay, so this is base for this angle, this is perpendicular for this angle, and this is hypotenuse. This is also base, this is perpendicular, and this is hypotenuse. Okay, so the ratio of perpendicular to the hypotenuse is always constant for given angle. Okay, so perpendicular upon hypotenuse is always sine theta. Okay, so and also here the perpendicular upon hypotenuse is sine theta. So these two values are constant, means uh, suppose we have smaller right angle triangle or greater right angle triangle, and if this angle is same, let this is 30, this is also 30, then the ratio of their perpendicular to the hypotenuse and the ratio of perpendicular to the hypotenuse will always be constant for any right angle triangle. So let us write the value. So for 0 degree, for 30 degree, for 45 degree, for 60 degree, for 90 degree. Okay, sine. So we know sine 0 is always 0, sine 30 degree is always 1 by 2, sine 45 is 1 by root 2, sine 60 degree is root 3 by 2, sine 90 is 1. Now for any angle, the sine 30 is always 1 by 2. Sine 45 is always a root 2 for any right angle triangle. So this is your exercise to check whether it is true or not. First, uh, create a right angle triangle with angle 30 degree and then find the ratio of hypotenuse to the base. Then make another right angle triangle which is little bit bigger but having same angle 30 degree, and then check whether the perpendicular hypotenuse for this and perpendicular hypotenuse for this is same or not, and this should be 1 by 2, means 0.5. So this should be your answer. Okay, so second law of refraction states that the ratio of sine of angle of incidence to the sine of angle of refraction is constant. Okay, so this is constant, and this law is called Snell's law. This law is called Snell's law. Snell's law. So whenever a question is asked, state Snell's law, so you have to write down this law along with this formula. Okay, now we have name for this constant, and this constant is called the refractive index. So this is our today's topic, is refractive index. So refractive index, refractive index. Okay, so refractive index is a relative phenomenon. So this is a relative means this depends on the media. Suppose we have two medium 1 and 2. So whenever we calculate refractive index, we always state with respect to which media. Okay, suppose the refractive index of medium 2 with respect to medium 1, because we are comparing the speed of light in medium 2 with respect to medium 1. So refractive index is just the ratio of the velocity. Okay, so from Snell's law, it gives the relation between the incident angle of incidence and the angle of refraction, but it is the just ratio of the velocities in these two media. Okay, we will study it. So refractive index of medium 2 with respect to 1. Now what is the notation of refractive index? So there are many notation like mu, like n, okay, or like eta. Okay, so we will study this one. Okay, we will use this notation and notation. So how will we write a refractive index of medium 2 with respect to 1? Simple, this is refractive index of medium 2 with respect to 1. Okay, what does n21 means? N21 means that a refractive index of medium 2 with respect to medium 1. And what is n12? N12 is refractive index of medium 1 with respect to medium 2. Clear? So means whenever we will calculate the refractive index, we should always have two mediums. Okay, so suppose from we will calculate the refractive index from Snell's law. Let this is air, this medium is air, and this medium is suppose this is glass. Okay, so here light is incident, and at this point we can draw normal, and suppose this is the angle of refraction, and this angle is 30, and this angle is 60 suppose, and this angle is 30. I am taking any arbitrary angle. So now we want the refractive index of medium 2 with respect to 1. Okay, so how we will calculate refractive index of medium 2 with respect to 1? First we have to know what is I and what is R. Okay, so since we want to calculate the refractive index of medium 2, this is the medium, and we want to calculate the refractive index of this medium. Okay, so angle of this medium we will always take as R. Clear? Because I am not showing the particular direction, but since we are calculating the refractive index of medium 2, so the angle of that medium will always taken as R. So angle R is equals to 30 degree. Okay, so this angle should be I, angle I should be 60 degree. Now what is refractive index of medium 2 with respect to 1? We have to apply the formula sin I by sin R, and this should be sin I is sin 60 divided by sin R is 30. So we know that sin 60 is root 3 by 2 and sin 30 is 1 by 2. So 2 is cancelled out, and this is going to be root 3. So n21 is root 3 in our question. Okay, suppose we want to calculate the refractive index of medium 1 with respect to 2. Okay, so a refractive index of medium 1, for which medium we are calculating the refractive index? Answer is 1. Okay, so if we want to calculate the refractive index of this medium, now the angle of this medium we will take it R. Okay, so now angle R is equals to 60 degree. Why it is 60 degree? Because we are calculating the refractive index of medium 1, and refractive index of medium 1, the angle is 60 degrees. So this is R. Whenever we are calculating refractive index of any medium, the angle of that medium you will always take as R. Okay, so I should be, if this is R, this should be I. So I should be equals to 30 degree. Now apply the formula. Sin I by sin R is sin I, what is I? I is 30 degree, and sin R is 60 degree. So sin 60 degree. So 30 degree is 1 by 2, and this is 1 by root 3 by 2. 3 by 2. So this is going to be 1 by root 3. Means refractive index of air with respect to glass is 1 by root 3. Clear? So this is how we calculate the refractive index of any medium. So whenever we are calculating the refractive index, first point we have to mention For which medium we are calculating the refractive index. Okay, so first write down the medium, then write down the angle of take the angle of that medium as r. Take the angle of that medium as angle r. Clear? Then your question will be correct. Okay, so sometime in many books it is written that this is written, suppose n21 is written 1 2. So don't get confused, this is also refractive index of medium 2 with respect to 1. So this is the refractive index for which medium we are calculating, and this is for with respect to. Okay, so suppose we have x and y. So it means refractive index of medium y with respect to x. What is this? Refractive index of medium y with respect to x. Clear? Okay, so many books it is given, sometime it is given 1 mu 2. This is also the same, refractive index of medium 2 with respect to 1. So in conclusion we can say n21 is equals to 1 mu 2. Clear? These three are same refractive index of same medium but different notation. So I will use this notation because this is given in your NCERT book. Okay, now the refractive index of medium in terms of velocity. Refractive index in terms of velocity. Suppose we have this interface and this is medium 1 having velocity v1, and this is medium 2 having velocity v2. So if I want to calculate a refractive index of medium 2 with respect to medium 1, so how we will denote it? Refractive index of medium 2 with respect to 1, and this is equals to v1 by v2. This is the formula. So we want to calculate the refractive index of medium 2. So the velocity of that medium, we want to calculate the refractive index of medium 2. So velocity of that medium will always be in denominator. Okay, so suppose we want to calculate the refractive index of medium 1 with respect to 2. Since we are calculating the refractive index of medium 1, so the velocity of that medium will be in denominator. This is v1. So velocity of medium 1 is v1. So it is denominator, and in numerator it will be v2. So these are the two formulas. Clear? Okay, so from here refractive index of medium 2 with respect to 1 is equals to v1 by v2, and refractive index of medium 1 with respect to 2 is v2 by v1. Okay, so one relation we can obtain from here is, so n21 is equals to v1 by v2. Okay, and n12, this is equation first, and n21 is equals to v2 by v1. We can also write is 1 upon n12 is equals to v1 upon v2. Taking reciprocal both side, we will get this is 1 upon n12 and this is v1 by v2. This is equation 2. So comparing equation 1 and 2, we get, so RHS is same, so LHS should also be same. N21 is always equals to 1 upon N12. This is the beautiful relationship between two refractive index. Okay, suppose it is given that refractive index of medium 1 with respect to 2 is 1.4, and a question is asked, find the refractive index N21. So what will you do? we know that, since we know that n12 is equals to 1 upon n21, so n21 is equals to 1 upon n12. So n21 is equals to 1 upon, what is n12? 1.4. So this is your answer. Clear? So refractive index is very simple, but you have to formula keep in your mind. Okay, so this is all for today. Refractive index in terms of Snell's law, refractive index in terms of velocity. Tomorrow we will do the numericals based on this refractive index. Okay, so tomorrow we will